You're looking at the Caldor Fire, which broke out just south of Grizzly Flats, California, and burned from August 15th to October 6th, 2021. With upwards of 24 Earth-observing satellites, detecting and tracking fires is an important part of NASA's purview. But this visualization gives us a detailed look at the past. NASA's latest generation of fire-tracking satellites observes the entire planet twice per day. Scientists use the thermal infrared images from each overpass to identify the active fire front, as well as track the behavior of large fires.
It's really important for us to be able to track fires as they change over time because the rate of spread, the intensity, and the total area that burns all contribute to the impact from fires on ecosystems, communities, air quality, and greenhouse gas concentrations in the atmosphere.
The yellow outlines you see represent the active fire lines, where the brightest shade of yellow shows the location of the current active fire lines. The gold lines show the position of the fire lines as they were 12, 24, and 36 hours earlier. The red dots indicate active fire detections, and the gray sections indicate total area burned.
The Caldor Fire started in the middle of August and burned for almost 8 weeks. But we know that most of the expansion happened in just the first 2 weeks, after which point most of the active fire detections were not at the perimeter of the fire as expanding fire fronts, but actually within the perimeter, showing areas where there was residual smoldering or flaming activity.
The latest generation of satellites are a partnership between NASA and NOAA. These new instruments have higher spatial resolution that helps them better detect fires. This also allows scientists to better locate the areas of actively burning fire and to be more sensitive to areas of smaller fire activity, including some of the smoldering fire activity that would not have been detected by previous satellites from NASA or other agencies. Here, we can see the Dixie Fire, located in Northern California. Better geolocation also allows scientists and fire managers to be more confident about where the fire is actually located on the ground.
Overall, the goal for our team is to be able to deliver active fire detection and tracking information in a way that helps link NASA's satellite capabilities with the needs of stakeholders on the ground. These stakeholders include fire managers who track and respond to fires in real time, and air quality managers responsible for forecasting and reporting how fire emissions create unhealthy air quality for communities downwind from large fire events. These data also help support new science. By tracking the fire every 12 hours, we can better pinpoint the conditions under which dangerous fires could occur and better anticipate the likely impact on ecosystems from hotter, faster, and longer fires in a warming world.
Hello there. I'm glad you were checking our posts. I would love to have virtual meeting with us Wednesday or Thursday after lunch hours. Also, don't forget that we have educational webinars on Thursdays all about climate change technologies, and maybe you should be our next guest so we can share your story at no cost. So send me a reply here and looking forward to seeing you soon.